This conference will now be recorded.
Hi, everyone. My name is Stuart, and we are going to have a short, a lesson on single-digit multiplication. So I'm going to start my screen sharing, so hopefully that won't take too long. Oop, there we go. So, I guess you can judge for yourself whether that took too long. So we're talking about single-digit multiplication, and I was looking at the slides that I had prepared, and there were, I don't know, 17, I think. And there were multiplication table was in there 3 or 4 times, but it didn't show up until a little bit later than I guess it should have, because the multiplication table is really sort of the central, the central thing, the central idea that we're going to be talking about. So this is it. I'm sure you've seen it, but here it is again. So it is a summary of all of the possible multiplication facts between single-digit numbers. In fact, I made this one so that you can multiply 11 and 12. I guess I'm not sure really why I included those here, but you can look at a row, like row 5, and then move over to column 7, and you can see that 5 times 7 is 35. I'm glad that these are all right, because I didn't find I actually made this one, so I hope they're all right. And there are 169, I guess, 168 other little squares here, and each one of them corresponds to a multiplication fact. And if you're seeing it for the first time, or if you're still new to it, it does look like there are an awful lot of them. But through repetition, you'll start to just remember them naturally, but you'll also sort of start to see that there are patterns. And this is a point that I'll come back to, I think, maybe at the end, but it's important that I think I'll make it now. That repetition is important. You can sort of look at the multiplication table and say that I understand it, and then move forward, and you can rely on your calculator, or you can keep looking, have a multiplication table printed out that you keep looking at. And that's one thing, and it is important to understand how to understand multiplication in that conceptual way. But for future subjects in math, like a real sort of familiarity with multiplication is important, and that comes from repetition, which I guess is daunting for some people. But so this is what we're going to be talking about, multiplication, and this is the multiplication table. So multiplication is one of the 4 elementary mathematical operations. I'm sure you've heard of all of them: subtraction, multiplication, addition, and division. So you take 2 numbers, and multiplication forms a 3rd number. The 2 numbers that you're multiplying are called factors. And sometimes there are other words. Well, not really. There are other words, but no one ever really uses them. There's a multiplicand, and I don't even remember them. You can always call them factors. And then the thing that you get here in this example, 3 and 7 are factors, and 21 is the product. So like conceptually, multiplication is useful for lots of different kinds of problems, solving, answering questions that are, it's very useful. So this is the slide that talks about the first use. Multiplication is how to count things in equal-sized groups. So you can see that we have 3 groups of Lego minifigures, and each group has 1, 2, 3, 4, 5, 6, 7, 8, 9. I think they're 10. I have a little dialogue blocking my view of this slide. And so there's 3 groups of 10, and that's what multiplication does. To find the total number of these little minifigures, you multiply 3 and 10, and that's 30. But what's important is the idea of using multiplication to count groups of equal-sized objects. So sometimes you'll see a word problem, and a clue that you'll want to use multiplication is the word of. You might see the phrase groups of, or packs of, or sets of, or various other combinations with the word of. It's not it's not a firm rule. The best way is to sort of think about the problem and sort of forget about math for a second and just try to understand what the words mean. But that is a frequent clue to that you might need to use multiplication. So this was just another example of the same idea. I thought that I had made a slide with the word per, which I will try to do for the next video, because that's another word that is often a sign you want to use multiplication. So here again, I'm going to try and close this. Okay, so now I can see the same slides that you were seeing. So you can say, we have 3 groups, and there are 1, 2, 3, 4, 5 minifigures per group. So the word per is another clue that you might need to think about multiplication. Something's it's not. Oh, sorry. So there you go. So here we have 3 cartons of eggs, and there are 3 rows of eggs in each carton. So how many rows of eggs are there? There's 3 times 3, or 9 eggs. And there are 1, 2, 3, 4, 5, 6 eggs in each row. So there are 9 rows and 6 eggs per row. So there are a total of 54 eggs in this little pile. So the multiplication table is important because if you study it and look at it, you can see patterns that help you understand multiplication of single-digit numbers, but also that help you understand multiplication of larger numbers and multiplication of, as you advance through math, you'll multiply numbers that don't look like numbers. They'll be variables or constants or expressions or other more complicated things that, are really just basically complicated numbers. And, being extremely familiar with multiplication, at every step of the way, it's going to make each successive step easier. So, so there's several that I wanted to point out. The first one is this. You can see 0. I hope you can see that one's a little smaller than the other one, but 0 times anything is 0. So you can make this bigger. No, I cannot. So 0 times anything is 0. So hopefully you can see here, 0 times 0 is 0, 0 times 1 is 0, 0 times 7 is 0, and also, 1 times, saying it the other way around, 1 times 0 is 0. 5 times 0 is 0. And, it seems really trivial, maybe, to when you're thinking about single digit numbers, but it's an important concept that, if you're really familiar with single digit numbers, it's an important, this property of 0 is an important property, because when you're dealing with bigger numbers or complicated expressions, that fact is still true. 0 times that big ugly expression is still 0. Yeah. So there you go. A little bit bigger, but that's what I was just talking about a second ago. So this is the second pattern in the times table that I wanted to point out, and the same comment applies here. It looks maybe a little trivial when you're looking at the times table. 2 times 1 is 2, and 7 times 1 is 7. But it's an important concept. It's true for all bigger numbers, and it's true for complicated expressions. When you take a thing and multiply by 1, that multiplying by 1 doesn't change it. So 6 times 1 is 6. Whatever you multiply by 1, it's that same thing. And at the bottom, I have 3 examples. 1 times 7 is 7. 1 times 4 is 4. 1 times 12 is 12. I think everybody would be really amused if they could see me just keeping. Every slide I keep pointing at my screen like you can see it. But so there you go. That you can see. So that's the second important pattern that you can recognize from the multiplication table. Is there another one? No. Well, this one is a little bit more complicated, I guess, because you can see I needed 3 colors and 4 colors. And so if you look at the multiplication table, you can see, and you look at this, and you divide it in half across this diagonal here. And I wish that I had made the this height of the table the same as this width of the table, because I think it would be a little bit easier to follow. But you can see, here you have 3 times 1, and here you have 1 times 3, and they're the same. And here you have 6 times 2, and then you flip over like a mirror to this other side, and you have 2 times 6, which is of course also 12. And let's just pick one more. So here you have 8 times 6 is 48. Here you have 6 times 8, and of course down here at the bottom I have two more examples. And I want to make that same comment a third time. This is something that is easy to see and hopefully intuitive when you're looking at the multiplication table, but it's true when you get to bigger numbers, and it's true when you get to fractions and complicated expressions with constants and variables. So I think that's why really practicing multiplication is a great help to everybody throughout the rest of their mathematical education, because they learn these properties, and that they sort of understand them almost instinctively when they don't have to struggle with them as they're trying to learn new ideas. Whoops. So multiplication, we talked about counting groups of equal size. There are a couple other things that multiplication can be used for. Multiplication can be used to compare the count or the number of different groups of things. So you can read that little example. I hope nobody's offended that I got a little bit political. But here I have 8 pieces of candy, and here I have a package, and it has 4 times as many pieces of candy. So, if you know your multiplication facts, then you can have pieces of candy in a larger collection to the number of pieces in a smaller collection, or the number of people, although of course that is not a single digit number. But it's the same idea. And I know I underlined the words that are like clues to to this sort of question. When you're comparing the count or the number of different groups of things, you'll see this sort of formulation. You'll see the word times, of course, which you'll see in lots of other types of multiplication problems, but you'll see maybe this phrase, times as many, and that'll be a clue that you want to use multiplication, or even just the word as, or together with many, as many. Lots of different ways of writing it, but these words appear in lots of different combinations. So you can count things, but things also you have the size, like a table or an animal aren't like some number of. They're not some number. They're not some count. Not some counting number high. They're but you can make the same comparison with size, and you see I think often the same language. So you can say that this bison, I think, is twice as large as this table. I tried to, bison are about 6 feet tall. I tried to make it look like that table was 3 feet tall. So multiplication can be used to relate the sizes of 2 different things when there's just one of them. You're not really counting. So here's another example. The previous example, that was the sort of multiplication that we're talking about with single digits. 2 times 3. The height of the table is 6. The height of the bison, did I say? But it's the same idea. Here we have the Sears Tower, and here we have a much taller building. It is not exactly twice as tall. It's not quite that big, but you could say it is about twice as big, or you could say it is about 3 times as big, or you could well, you couldn't say that. You could say it is about 2 times as big. You could say it is about 2 times bigger. You could say that it is about 2 times larger, and so these are other hints and other phrases that are clues that you're comparing the size of 2 things and that you need to use multiplication. So I guess the third application, I wish I had thought of that word a few slides ago when I was struggling to reach it. Another application of multiplication is finding areas. So this is a diagram of layout of a bedroom, and you can say that the bed is 10 feet long and 8 feet wide. So how much area of the floor is covered by the bed? Well, you would multiply 10 times 8. And I guess this would be a dresser, and maybe it's 3 feet by 6 feet. And how much space is taken up on the floor by this dresser? Well, that's another.
Sorry, your has lost connection to the internet.
That's another multiplication problem, and would be, what did I say? 3 times 6. So 3 times 6 is 18. And you can do that with the nightstands and whatever that is, and whatever that is. And you can do it with much, much bigger things. This is a farm. And you could say that, if you measure this in feet or in yards or in meters, they would be much bigger than single digit numbers, and not really the sort of problem that we can handle yet. But, we could pretend that it's, 1 mile by 5 miles, and we know that the area then would be 5 square miles. So this is the fourth and final application of multiplication that I think I'm planning to discuss. So you can count combinations or arrangements with multiplication. So I was gonna try and type. So if you have a choice every morning to wear 2 different kinds of pants and wear 4 different kinds of socks, then how many arrangements, how many ways can you do that? Well, you can wear the blue pants and the orange socks, the blue pants and the striped socks. That's not 2. The blue pants and the blue, I think, socks. The blue, that's 3. The blue pants and the dotted socks is 4. The red pants and the orange socks, the red pants and the green, sorry, I'm partially colorblind, is 6. The red pants and the blue socks is 7. And the red pants and the dotted socks is 8. So we had 2 and 4, and we got 8 combinations, and that's not a coincidence, because the way that you count that is you multiply 2 times 8. And that makes sense, because for each pair of pants, there's 4 different arrangements or combinations that you're going to have. You have 1 arrangement with the blue pants for each of these, and then you have 1 arrangement for the one arrangement for each of the socks for the red pants. So you have 4 arrangements for the blue pants, and you have 4 arrangements for the red pants, and you have 2 groups of equal size things where that size is 4, and that's this is like a special case of the sort of primary application of multiplying, counting equal-sized groups, the total number of objects in equal-sized groups. And you can extend that if you've got 2 pair of pants and 4 pair of socks and 3 shirts, then you can multiply it all to get 2 times 4 is 8 times 3 is 24, and that's how many possible ways there are of dressing yourself in the morning. If you're going to wear 1 pair of pants from a choice of 2, and 1 pair of socks from a choice of 4, and 1 shirt from a choice of 3, and now if we want to add the tie and do it all together, or it's going to be 24 times 4, which is not a multiplication fact that we're going to cover in this lesson, but you can put it in your calculator and you can see that that would be 96. And you can multiply, you know, if you know what shirt you're going to wear and you know what pants you're going to wear, then you have socks and ties to choose from, and how many ways of getting dressed with a choice of 4 ties and 4 different pairs of socks. Well, that's 4 times 4, which is 16. So, you know, probability is something that is covered in the high school equivalency math program, and this is an application of multiplication that will definitely come in handy when you get to that. So it's good, and I said, you know, on the very first slide, that you want to be really very familiar with all of these facts. And I know that, you know, 100 and whatever facts, it seems like a lot of them to master, but you know, it pays off. So one way to sort of build that familiarity is to think about multiplication in the other direction. So here you can count all of these little circles. 1, 2, 3, 4, 5, 6, and I'll spare you. There are 24. So, well, how can you multiply 2 numbers to get 24? And you can see how I arranged them. That you know, 4 rows of 6 circles gives you 24. But you can also think of it in terms of 6 columns of 4 blobs gives you 24. And you know, maybe I'll pause for a second, and you can pause the video and try and think of as many other ways of multiplying 2 numbers to get 24 as you can. So I mean, I don't know if anyone, I paused the video there, but let's look at some other ways of multiplying 2 numbers to get 24. Hope I can get back to that easily. Oh, there we go. So we can do, you know, 8 times 3 is 24. And remember, I hope that means that 3 times 8 is also 24. And 12, I guess, is not a single digit number, but I put it on my multiplication table. So I guess you can see that 2 times 12 is 24 because you have 2 groups, of 12 things. And you can think of it the other way around. You can think of having 12 groups of 2 things. How do I get this? Percent. And that's a good exercise. You know, you can do that with any other number that you see on the multiplication table. You can practice. You know, you can practice these skills, these facts, with you know, a lot of different ways. you can have a flashcard, and it can ask you, well, what's 6 times 3? And that's important. But you can reinforce these skills by looking at the back of the flashcard and trying to think of what two numbers were multiplied to give you 24 or 64 or so. I guess this is a sort of a slightly different slide, because it's not really strictly about math. It's I guess about learning math, which is a little different, So I have a calculator. Why are arithmetic skills important? And this second one here is something that I know I mentioned once, maybe more than once. These properties of multiplication are something that you'll need, at every stage of your mathematical education. And the more familiar you are with them, the less you struggle to recall them, the easier it will be to it will be to layer on new concepts. And I guess that's maybe what I meant here with this first point. It's important to understand. A lot of these slides were targeted at understanding, what does multiplication do? What are the applications of multiplication? Counting groups of equal size objects, finding areas, counting combinations. But and it's important to understand, what those and the properties, multiplying, the identity of property, or how 1 multiplied by anything, how 0 multiplied by anything is 0. It's important to understand those things, but it's also important, I think, to be familiar with the basic facts of the multiplication of the times table. 7 times 6 is 42. Being able to recall that as quickly as possible is something that will free your brain to think about the new ideas that you're trying to learn in the future. And that's something that that may seem difficult, but it does come with practice. So these, I guess, here at the bottom are examples of, I guess I couldn't I wanted you to believe that there's math after multiplication. So this is something you'll see maybe very soon. So the area equals length times width. And these aren't numbers at all. Well, I mean, they're numbers, but they're represented by variables, and conceptually, that's a big jump. But if you are familiar with multiplication, the facts of the multiplication table, and the properties, then learning how to deal with variables like L and W, and expressions like L times W, and equations like A equals L times W, all of those things become slightly easier. So I can't even remember if I said what the L and the W and A are. Area equals length times width. That is the formula for finding the area of a rectangle, which we used in the slide about area. This is a more advanced equation, but we're still multiplying. We're multiplying this A times this S times this I, and those are all numbers, and the minus sign is maybe something that it will be a new concept that you'll see in weeks or months, and this symbol here is something that may be quite some time before you see, but we're still using multiplication, and it's still important that we know that A times S is the same as S times A, important that, if we multiply by 1 or multiply by 0, that we know what happens. And I suppose I should say that this is one of a handful of equations that people are using now to help understand the progression of COVID-19, of the coronavirus 19 disease. S here is the number of people who are susceptible to the disease. I here is the number of people who are infected by the disease. A is some other number that relates this to this, and this S over here is a little different from this S. This S is how fast, this S on the left is how fast this S here on the right is changing. That's all, a lot of stuff that you absolutely do not have to know now or soon even. But the point is that you may be learning some of these things eventually, and you need multiplication to do it. So I said that building and maintaining these skills is done with I guess a lot of repetition. And one of the things that you can do is flashcards. I have I'm holding some flashcards, but I don't think it's worth getting out of the slideshow to show them to you. And everybody knows what a flashcard looks like. And you can find flashcards on I'm sure in whatever app store you may use, or online, or another thing that you can do to practice and maintain your multiplication skills is skip counting. That's counting in multiples. So you can count in multiples of 5, 5, 10, 15. You can start at different places, start at 65 and 70, 75, 80. You can count backwards. That's helpful. Start at 49 and count backwards in sevens, 49, 42, 35, 28. And doing those things repeatedly sort of builds like a muscle memory, the same way that practicing a golf stroke or a tennis stroke or a basketball free throw shot builds muscle memory. And the final way I think that you can build and maintain arithmetic skill is to use these. When you finish the packet on single digit multiplication and you move on, and you're working with equations or expressions or probability or geometry, there's it's easy to pick up your calculator and to poke anything in there and get an answer immediately. But and that's good. But before, just try to see if you can recall it. And if you can't, then you can use your calculator. And if you're unsure, you can check it with your calculator. And when you're doing more difficult problems with multi-digit multiplication, you probably want to, you'll learn how to do that and then use your calculator. But still, every once in a while, take a piece of paper and a pencil and strengthen, reinforce these basic skills. Another way of sort of getting through the the multiplication table, I said a couple times, has all of those facts, and handling such a large group, it becomes a little bit easier if you think of them in groups. So you can think of multiplying by 2, and you can think 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12. And what you'll see is here, we have a 2. I guess the 2 times 1 is 2. And here we have 2 times 7 is 14. We have the 4, a 4. 2 times 8 is 16. We have a 6 and a 6. 2 times 9 is 18. We have the 8 and the 8. So you see there's a pattern when you're multiplying by 2s, and at the ending is going to be a 4, a 6, an 8, or a 0 or a 2, and that cycle repeats. And that's something that's also true with larger numbers. And that's something that can help you learning the multiplication table, and it's something that I think can help you when you're learning more complicated arithmetic skills. And you can do the same thing with 5. 5 times 1 is 5. 5 times 2 is 10. And here, this pattern is even simpler because you go, here the ending digit is 5 and then 0, and now we're back to 5 already. And then 5 times 4 is 20 with a 0. 5 times 5 is 25 with a 5. 5 times 6 is 30. You have the 0. So, and this is again true with single digit numbers and adaptable to larger digit numbers. So it's something that can help you break that gigantic list of facts that you have to memorize into smaller, more manageable groups. And then this is an important one, because when you multiply by 10, 10 times 2, you take that 2, you put a 0 on the end. 10 times 3, you take that 3 and you put a 0 on the end. And that pattern, as you can see, it holds through the rest of these numbers. And it's also a pattern that can be adaptable to to larger numbers when you get to learning those. It's something that can help you with the multiplication table, and it's something that can help you with bigger multi-digit numbers. So the multiplication table, it starts out looking really big, but multiplying by 0, we talked about that. So manageable. Multiplying by 1, we talked about that. Multiplying by 10, we talked about that. And then these patterns, multiplying by 2 and 5, they're not as easy, but with if you practice them sort of together like this, again they sort of form a imprint on your brain, and you can do this with multiples of 3, and multiples of 7, and multiples of 4, and you get similar patterns. So you can take flashcards if you have them, and pull out the 7s and work with them together. Not all the time, but doing lots of different types of drills is going to be helpful. Sorry, I keep pressing the arrow and it doesn't. This is the last. No. So this is the last slide, and I wanted to just do two quick more things with my camera. How do I stop sharing? There we go. How do I start? So I guess hopefully you can see me again. I wanted to end with I guess questions for you. 2 different types of questions. And again, you can if everyone who's watching this will be watching this on YouTube. So I can ask a question and you can pause the video and you can think about it, and you can answer. So this is more Lego, very dusty. Sorry, but it's a tiny. Hopefully you can see it. It's a tiny little chessboard, and it has. They're called ranks and files, I guess. So 1, 2, 3, 4, 5, 6, 7, 8 ranks or rows. And you have 1, 2, 3, 4, 5, 6, 7, 8 files or columns. So you have 8 groups of 8, and you can answer how many squares, how many spaces are there on the chessboard. And this is a second little problem, Rubik's Cube. So you've got 3 columns, 3 rows, and how many squares are there on this face? So now there are 1, 2, 3, 4, 5, 6 different faces. So how many stickers are there? And then this face here, we counted 1, 2, 3 by 3. That's the number of cubes. And then there are 1, 2, 3 layers. So we have 3 times 3. Take that number, multiply by 3, and then how many cubes are there in a Rubik's Cube? And then the last thing that to do is I want to have you think of your own questions. You know, I think of each of the applications of multiplication and think of as many word problems as you can. You know, multiplication can be used for combinations. So think of a word problem that uses multiplication to answer a question about combinations. Multiplication can be used to count groups of equal-sized groups. You know, count the total number of objects in equal-sized groups. So think of your own word problem that will you know, that you could ask someone else where they would need to use multiplication to do that. And there were, you know, area and comparison, comparing sizes and comparing numbers, and then counting numbers. So there were several different applications of multiplication. Try to think of word problems that use multiplication in all those different ways, and I think that'll really help you understand multiplication. So I guess that was an awful lot for single-digit multiplication, and I hope it was helpful. And thank you very much.